VLSos here. This is a video lesson on mean value or average value. Let's remind ourselves what we mean by average and how to find an average. Imagine that data was collected and represented as a bar graph or histogram. The height of a bar represents the value of the data collected, in this case 4 and 2. Numerical data 3, 4, a 1, and another 4. If we wanted to find an average of these 6 values, then the way to go about that, to calculate it, and another name for average is mean, of course, is to add up all values and then divide by the number of values. This is how a mean is calculated. In this case, we have 6 values, and we would add up 4, 2, 3, 4, 1, and 4, and then divide by 6. Visually, we can find the average by taking the high points of this data and filling in the low points. When we do, we could imagine taking 1 off of this top 4 and filling it in on top of the 2. If we took another one off this 4 and then a third and filled in on top of this 1, then every bar in this chart would have the same height, in this case 3. And if all of the bars have the same height, then we could easily understand their average to be 3. We can approach finding the average value of a function with the same conceptual understanding. The values of a function are much more sophisticated. The function could be anything, curve, and be complicated. But if we were to find the average from A to B, then we would expect that there is some number that we don't yet know the value of that represents a height or a value of the function, such that at that number, the area created by the values of the function that are above that location fill in exactly the area of the values that are below that function. In this case, in my visual presentation, it looks like the average that I would find would need to be a little bit higher because these areas need to be equal measure in order for the high part to fill in the low part exactly. But what we have here is an understanding that the shape of the area below this average, if it were filled in, is a rectangle. And the height of that rectangle is the average that we've labeled C that we're trying to find. So in this presentation, we could think of the average or the mean being equal to C. And the area of this rectangle, labeled this way, is C times the width of the interval, or the base of this rectangle, B minus A. This rectangle will have the same area as the area under the curve from A to B, because it was the area under the curve that we modified by taking the high point and filling in the low point. So if the rectangle's area is its base times its height, then that's going to be equal to the area under the curve that it came from, which can be represented as the definite integral from A to B under this curve that we could call f with respect to the horizontal axis. And if we have given the letter c to represent the mean or the average value of the function on this interval, then we can solve this equation that compares the rectangular area to the area under the curve for c by dividing by the width of the interval, a minus b. When we do, we get the expression, the mean c is equal to the area under the curve divided by the width of the interval. The average value of a function on any interval can be calculated with this expression. This expression intuitively matches how we think of an average. The average is we add up all the values and divide by the number of values. In this case, adding up all the values was finding the area under the curve, which is the sum of all the function values. And we divide by the number of values that we added up, which in this case is the same thing as the domain under that curve, the width of the interval from A to B.